Eu pedi talvez aqui ao João para vermos a última apresentação. Será uma intervenção do Tom Chalko, portanto, da Scientific Engineering Research. Fará aqui uma intervenção por vídeo. Forças.
Hello and welcome to my presentation. My mission today is to show you that global warming is not restricted to climate. The entire planet is experiencing consequences of disturbed energy balance. When we expand our context, it turns out that dangers of global warming are far greater for humanity than implied by climate change. I'm sure that you agree that good planets are not easy to find. Let's begin with the atmosphere. The atmosphere is an interface between our planet and space. All radiant energy arriving at Earth and leaving Earth must pass through the atmosphere. Properties of the atmosphere influence the energy balance of Earth. Energy balance occurs when the average energy from the Sun plus heat generated inside Earth is equal to the average energy radiated by Earth back to space. Global warming occurs when Earth generates and absorbs more energy than it is able to radiate to space, because the atmosphere traps heat. In 2005, the difference was about 1 watt per square meter. The atmosphere comprises very tiny percentage of Earth mass. By restricting our consideration to climate, which is a condition of the atmosphere, we disregard almost the entire system that is subject to global warming. Earth interior must be admitted for consideration. When more energy from the Sun arrives through the atmosphere that can escape back to space, the heat generated inside Earth is trapped, and the planetary interior temperatures rise. If global warming is real, warming of Earth interior is real too. The source of the interior heat is 55% nuclear. Decay of 3 isotopes of uranium, thorium and potassium generates 24 trillion watt, or 55% of the interior heat. The source of the remaining 20 trillion watt remains a mystery. Let's have a look at some symptoms of warming of the planetary interior. Earthquakes, tsunamis. How many tsunamis do you remember reported in the last 100 years? Haven't they all occurred in the last 11 years? How many times in the history of aviation, air traffic has been disrupted by volcanic ash? Have you noticed that such disruptions began to happen every year? How many sinkholes do you remember reported in your lifetime? Haven't they all happened in the last few years? Other symptoms include accelerated movement of tectonic plates and so-called slow earthquakes. Let's have a look at the 12 largest earthquakes in the last 50 years. Areas of circles that show earthquakes are proportional to earthquake energy. 11 out of 12 largest earthquakes occurred in the last 14 years. 9 out of 10 hottest years on record occurred in the last 14 years. Is it a coincidence? Can we predict when and why the largest future earthquakes are most likely? Let's begin with a brief introduction to tidal forces. Tidal forces are differential gravity forces that originate from gravitational attraction by Moon and Sun. They cause tides and deform the shape of Earth. Tidal forces of the Moon dominate because of Moon's proximity. Maximum tidal forces and highest tides are associated with Moon's perigee, when Moon is closest to Earth, and a linear alignment of Moon, Earth, Sun, which happens during full moon and new moon. Minimum tidal forces and smallest tides are associated with Moon's apogee, when Moon is at the maximum distance away from Earth, and a right angle alignment of Moon, Earth and Sun positions, which happens about 7 days before and after each new moon. In this configuration, the combined lunar and solar tidal forces reach minimum. It is reasonable to expect that triggering of large earthquakes should be associated with periods of maximum tidal forces and the corresponding maximum deformations of the crust. Let's have another look at the 12 largest earthquakes in the last 50 years. The graph shows the association of individual earthquakes with new moon, full moon, perigee and apogee. Bars on the graph show earthquake energy, and digits indicate the number of earthquakes. As we expected, the correlation between high tidal forces and large earthquakes seems quite good. 7 out of 12 earthquakes occurred during perigee, when moon was closest to Earth. 11 out of 12 earthquakes were associated with either full moon or new moon. But there is something strange about this graph. The largest single earthquake on this graph occurred during apogee, when moon was at the maximum distance away from Earth. It is difficult to disregard this earthquake because its energy was larger than the energy of all other earthquakes on this graph combined. The other strange thing about this graph is that the second largest earthquake in the last 50 years is missing, because it was triggered 7 days after new moon. A closer inspection reveals that magnitude 9.1 earthquake was triggered during the longest possible apogee, when tidal forces caused by the moon were the smallest they can ever get. Magnitude 9.0 earthquake was triggered exactly 7 days after new moon, when the combined lunar and solar tidal forces reached their minimum. So, the 2 largest earthquakes in the last 50 years, an order of magnitude larger than other prominent earthquakes, were triggered when tidal forces were extremely small. How can the smallest tidal forces trigger the largest earthquake? Could there be a violent quake triggering mechanism inside Earth that we haven't yet admitted for consideration? Can some part of the planetary interior become unstable when tidal forces are too small? Does this instability depend on global warming? Let's have a look at the internal structure of Earth. This structure has been verified using seismic tomography, a technique that relies on observations of seismic waves that travel all the way across the interior. The crust is really thin in comparison to the size of Earth. Underneath the crust is a semi-solid, semi-liquid mantle, shown here in 2 orange layers. Deeper is the liquid part, shown here in yellow. The deepest section of Earth, shown by the brightest color, is a solid core. We know that the Earth's inner core is solid because it reflects seismic waves. Imagine hovering above the North Pole and looking down through Earth with a special vision. This is what you would see at equatorial plane. Earth spins. Solid core suspended in a liquid experiences buoyancy-gravity balance. Since buoyancy and gravity forces are both zero in the concentric position, the core equilibrium becomes eccentric. Tidal forces cause the core eccentricity to follow moon. Motion of the solid core in a viscous fluid dissipates energy, turning some of the kinetic energy of Earth rotation into heat. Tidal energy dissipation slows Earth's spin. A 20 trillion watt tidal break causes each day to be longer than the previous day by about 0.35 microseconds and would take nearly 8,000 years to lengthen a day by 1 second. Eccentric movement of the core, driven by tidal forces, is responsible for Earth's magnetic field. Imagine hovering above the North Pole, but this time we keep rotating slowly, in such a way that Moon is always directly behind us. In this slowly rotating frame of reference, the center of the core is stationary. If Earth did not spin, the situation would look as in this picture. The core equilibrium is determined by a balance of 4 forces. The tidal force Ft that pulls the core towards Moon, the gravity force Fg that pulls the core back towards the planetary center of mass, the buoyancy force Fb that pushes the core from a high pressure zone in a liquid to a lower pressure zone, trying to increase the core eccentricity, the centrifugal force Fc that also tries to increase the core eccentricity. Now let's consider Earth spinning. When Earth spins, The liquid surrounding the core tries to drag the core along with it. Drag force Fd represents the sum of all forces exerted by the flow on the core. Which force prevents the core from being dragged along by the liquid? The only force that can hold the core against the flow is the tidal force Ft. If the tidal force succeeds in holding the core against the flow, the core equilibrium is reached at some angle alpha. When tidal force Ft is too small, the core equilibrium becomes unstable, and the drag force Fd takes the core for a ride. Phenomenon of stability loss in hydrodynamic bearings caused by insufficient transverse load is very well known in rotordynamics. Hiccup oscillations that follow the loss of stability of the core have several consequences. They disturb the location of the Earth's center of mass. They disturb Earth's axis of rotation. They create anomalies in Earth's magnetic field, and they can trigger tectonic events and large earthquakes. Why is a loss of stability in spinning systems a violent phenomenon? Instability provides a mechanism for energy transfer from kinetic energy of the spin to vibrations. Hiccup oscillations that follow the loss of stability of the core can be quite energetic because the kinetic energy of Earth's spin is a very large energy source. Let's have a look at earthquake energy history over the last few decades. The red line represents the trend. Can you see how dominant are the two hiccups? These hiccups dominate the trend. In the period of time when climate warmed up a small fraction of 1 degree, the annual energy of seismic activity on Earth has increased several-fold. The largest future earthquakes and disturbances to Earth's axis of rotation are most likely when tidal forces reach their minimum values. Can we estimate tidal forces to see when the core instability is most likely to happen? If my tidal force calculations presented here are accurate enough, 5 dates stand out in the next 12 months. You can read what they are. The obvious question is how small the tidal force needs to be to cause instability of the core. Have a look at the timing of magnitude 8.3 earthquake on September 16 this year. Could this be a hint? What happens when the core and the surrounding liquid warm up due to global warming? Excess heat arising from insufficient cooling causes a temperature rise that lowers the viscosity of the liquid surrounding the core. Lower viscosity liquid loses some of its capacity to lift the core, and the core eccentricity grows. Growing eccentricity causes centrifugal, tidal, and drag forces to grow. Growing drag increases the energy dissipation, creating more heat. It is a thermal runaway system. What is the reason of this overheating problem? The reason is global warming. Can we diagnose the current situation inside Earth? Is there any evidence that Earth's core eccentricity grows now as we speak? Actually, there is. Have you heard that our Moon seems to move away from Earth by about 3.8 centimeters each year? How can Moon accelerate itself to a higher orbit? If this was true, why can't we design satellites that would accelerate themselves to higher orbits? Growing eccentricity of the planetary center of mass is much more realistic explanation. Have a look at these two pictures. When the planetary center of mass becomes eccentric, the eccentricity is directed by tidal force towards Moon. What happens when the planetary center of mass remains where it was supposed to be on its trajectory, but it becomes eccentric? The surface of Earth becomes more distant from the Moon. Annual increase of the distance between Earth and Moon surfaces implies that the Earth core eccentricity grows each year and has been growing for at least 20 years. 3.8 centimeter per year eccentricity increase in Earth's center of mass means that the inner core eccentricity increases about 30 meters each year. Measuring Moon to Earth surface-to-surface distance can and should be used to monitor changes in Earth core eccentricity. Humanity is unaware of the real danger because for some reason the focus stays on climate. This restricted context makes the real emergency that we are actually facing debatable. In the meantime, the damage caused by sustained energy imbalance of our planet occurs faster than it can be repaired and occurs violently. Earth core has rung the alarm bell twice already. What can we do? What can we do to restore Earth energy balance? The planetary interior desperately needs cooling. Can we dim our sun's output? Can we change Earth orbit to move it further away from the sun? Can we pay Earth interior to reduce heat production? The only thing that we can do is to stop polluting our atmosphere as soon as possible. To restore Earth energy balance, our rate of greenhouse gases release should be much smaller than the ability of ecosystems, such as forests and oceans, to absorb these gases. Zero emissions should be our urgent target. No other target makes sense. We need to act now. If we fail to act now, thermal and nuclear conditions of the core will become irreversible, and we won't have a second chance to address the problem of global warming. Combined effect of many local individual efforts can be significant if there is enough of us. Our conscious commitment can make a huge difference to our future because we can influence other people, including our leaders. We need to think globally and act locally. Direction is to eliminate the use of fossil fuel energy. It belongs to 19th century museum. The second direction is protecting ecosystems from pollution and other disturbances. Ecosystems make oxygen for us to breathe and can absorb greenhouse gases already present in the atmosphere. Our spacecraft. It's our home. No spacesuits required. Nuclear powered, inside and out. Unfortunately, there is no user manual. Ecosystems make oxygen free for all to breathe. Free food and shelter for every creature in every ecosystem. Free magnetic field protection from dangerous high-energy particle flux. Free journey around Sun at 30 kilometers per second with great views in all directions. No tickets, no bookings required. Everyone is welcome. Can we take care of Earth? It's our home. Some time ago, people believed that Earth was flat. And then people believed that Earth was standing still. And then people believed that the moon moves away from the Earth. Today, I'm telling you that the core of our planet moves inside the liquid planetary interior, and that our future depends on parameters of this motion. Can we take care of Earth?
Quero também agradecer ao painel pelas suas intervenções Não sei se há alguma recomendação por parte da organização. Estamos em cima da hora para o almoço e retornamos às 2 da tarde para o painel, para a sessão de português. Muito obrigado a todos.